morning. Good evening. Welcome to the Milesight IoT Academy. Thank you so much for taking the time to join us. Today we're here to talk about the market trend from machine-to-machine communication to artificial intelligence of things. In this webinar, we'll provide a brief overview of wireless technologies with a focus on low-power wide area network technologies that enable long-range, low-power communication. We'll dive into the growth of machine-to-machine, Internet of Things, and artificial intelligence of things. Following that, I'll share insights on our comprehensive product portfolio. You will come away with a deeper understanding of current Internet of Things technology trends and how you can leverage these advancements in Milesight products to drive innovation and efficiency in your businesses. Without further ado, let's try to understand the various communication protocols available to set up an IoT. The first is the cellular. This enables the cell phone communication through an antenna situated within the coverage by service providers, the standard mobile networks including GSM or GPRS, 4G and 5G. The second protocol is the Wi-Fi and is based on 5 GHz frequencies. It provides internet access within a certain range and are an affordable option. It has well-protected protocols. The third is the radio frequency. It's the easiest form of communication. A few examples are Zigbee and Z-Wave, which use low-power RF radio. It consumes low energy, which is very advantageous, is relatively simple to configure. The fourth is RFID. It uses wireless electromagnetic fields to identify sensors and objects. Good thing about it does not require power. The fifth is Bluetooth, which is useful for short-term and short-distance data exchange. It's present in every smartphone with high security. The final one is near-field communication, or NFC. It uses electromagnetic induction and loop antennas. It comes with encryption, has low-speed communication, and is used for short-range data exchange. So we know these technologies are the key pillars for all the audio secrets around the mobilities. We see a lot of customers from agriculture, utility, mining, or smart office and smart buildings deploy different wireless technology for their industries. In the conversation, our customers always come to us with questions. Can we find a single radio technology that meets all requirements? Well, it's an interesting topic. Yes, absolutely, if we had that one. That'd be great. But what is reality? Can we really find one that could be a different story? From our conversation with customers, we see so many requirements flying everywhere. How much data will be transferred? How far the data source is from the internet? How much power is required? How far away can be connected? And how high the cost is for the service? We keep talking about the reliability, performance, power consumption, and so on. The widespread use of smartphones and the choice of Wi-Fi or Bluetooth radio standards offer very convenient connectivity. But for applications using multiple sensors to communicate very small amounts of data at very low speeds, the traditional cellular networks and short-range wireless technologies are not the best option, and this is where low-power wide area network come in. It opens up more options for the future Internet of Things. New devices can take advantage of the new LP1 technology and provide better performance. The LP1 space consists of a variety of standard-based and proprietary technologies, most of which are operating in the unlicensed radio spectrum, except the circular-based standard. So here are the NB-IoT and LTE and LTE-M. They are cellular network-based, and the techniques Sigfox and LoRa, they are non-cellular-based technologies with very obvious development. They are the most popular low-power wide area techs in the IoT applications. Those technologies are designed to meet different data rates, energy consumption, scalability, and coverage requirements. There is no single technology that covers all of applications simultaneously based on the intended functionality of your product. It should be relatively simple for you to immediately determine which group of technologies you need to consider. For example, if you require two devices separated by 30 feet, about 10 meters, to transfer low amounts of data, then it doesn't make sense to use any of the long distance or high speed wireless technologies. For example, Milesight has LoRaWAN sensors. When we configure them, we choose the NFC to realize the wireless setup. The idea behind LP1 is not new. Applications with low throughput requirements have been around for decades. So next, I'll touch on the LP1 development and share the common advantages. In the late 1980s and early 1990s, there were similar topologies and network architectures, but they weren't called LP1s, but they played a crucial role in shaping the development of LP1. Samples include the data take. It was a narrowband wireless network originally developed by Motorola. It is specifically designed for the data-only applications, operates in the 800 MHz, and it was known for its superior ability to penetrate buildings when compared to higher speed networks. In the US, it is still deployed for building applications under the name of ARDIS Network. AlarmNet. Net is a wireless technology developed in the middle 80s to monitor alarm panels. It operates over the 900 MHz band and can only transmit small amounts of data at low data rates. Today, the technology is owned by Honeywell and is still quite popular. Later, in the beginning of 21st century, the machine-to-machine industry moved to GSM and GPRI's technologies, which offered a coverage in everywhere at very low hardware cost. Today, the telecom industry is moving towards 4G and 5G networks with higher data rates and capacity to meet the demands of data-intensive applications such as call centers, surveillance networks, and so on. At the same time, the emergence of the Internet of Things and its billions of connected devices have reinforced the interest in low-cost and low-data services. So the emergence of Sigfox and LoRa technologies has provided an even better alternative to the machine-to-machine industry. LEP1 technologies share some common characteristics. They have emerged to complement existing wireless technologies and satisfy the wide range of requirements of the different Internet of Things applications. More specifically, LP1 technologies were designed to target applications characterized by infrequent transmission of small data from a large number of devices spread over wide areas, with a minimal cost of the devices and their deployment and a low power consumption to ensure the devices can operate autonomously for many years. The booming Internet of Things market has led to increased use of LP1. These networks fall into two categories. One is the non-cellular networks like Sigfox and LoRa that are specifically designed for the Internet of Things, and another one is cellular networks that use existing mobile networks like LTE-M and NB-IoT. Let's explore them one by one. LoRa is specially designed to transmit small data packets of between 0.3 and 50 kilobit per second. LoRaWAN protocol was designed by a French company, then acquired by Semtech, the company that set up the LoRa Alliance. This association is made up of operators and manufacturers who want to promote the development of compatible networks. LoRa is commercialized via operators such as Orange, but remains an open source network that can be developed and used by any business. The only condition is that they must use LoRa chips. This means that users can switch from one operator to another and enjoy the benefits of roaming agreements if they use companies who are members of the alliance. LoRa Alliance is a global association of over 170 network operators. Some of the member companies include KPN, Cinet, Digita, Swisscom, and many others. The open standard LoRaWAN protocol and the large number of network operators make it easier for companies to adopt the technology and customize their solutions based on their needs. Additionally, the LoRaWAN Alliance facilitates interoperability testing and certification, which helps ensure device compatibility and reliability across different manufacturers. LoRa's main competitor is Sigfox. Created in 2009, Sigfox is a groundbreaking French IoT company specializing in machine-to-machine and acquired by a Singapore company last year. According to the operator's figures, this low-speed network currently has over 2,000 antennas across France and presents in more than 70 countries and regions. If users opt for this technology, then emitting receiving devices must be certified by Sigfox, using the closed network software and hardware. This guarantees compatibility and makes for easy interoperability between covered countries. Sigfox proprietary technology offers advantages in terms of control and security, while the LoRaWAN ecosystem provides more flexibility and scalability. Sigfox has also established partnerships with various network operators around the world to provide coverage for their IoT network. These partners are responsible for deploying base stations, managing the network infrastructure, and providing local services to end users. But its ecosystem is more limited compared to the LoRaWAN ecosystem. Although LoRa and Sigfox technologies form a significant part of LP1 today, mobile network operators aren't far behind in rolling out cellular LP1 for machine-to-machine applications. The organization 3GPP offers IoT standards LTE-M and NB-IoT that use existing mobile networks. Now we know both of them can extend the battery life of resource, constrain devices, and may operate effectively at distances of around 20 to 100 kilometers. They are standardized, secure, and operator managed within the licensed spectrum. Then what are these key differences then? Let's classify them in some neat and useful categories according to their key performance parameters. While both are operating within the licensed spectrum, the bandwidth of the LTE-M is 1.4 MHz, and NB-IoT offers no more than 200 kHz. What that means in practice is that the smaller bandwidth of NB-IoT typically translates into longer ranges while negatively impacting throughput. Therefore, thanks to its broader bandwidth, LTE-M gets a little less range but much higher throughput. Ranges depend on many factors, such as methodology and terrain conditions, reaching 15 to 20 kilometers on average in case of LTE-M and up to 35 kilometers for the NB-IoT, yet with no trade-offs on the efficiency of data transfer. Roaming is possible with LTE-M, so that moving from one operator to another is possible, but this feature is not yet in place for NB-IoT. According to studies, it is possible to achieve even 15 years of battery lifetime for both of them, of course, depending on the project requirements. Still, where there are higher transfer rates, as in LTE-M, the batteries will be drained much faster, so NB-IoT will be the obvious choice for the projects where the longer battery lifetime is more important than data transfer speeds. NB-IoT is ideal for simpler static sensor applications, such as smart metering, smart agriculture, environmental monitoring, while LTE-M is more suitable for fixed and mobile applications, such as asset tracking, retail vending machines, smart home security, and so on. Both LTE-M and NB have global coverage and are supported by major network operators worldwide. There are now over 100 NB networks and over 52 LTE-M networks, and the number is growing all the time. Some of the data that I'm going to share is based on the research that LoRa Alliance has done in 2022. Its partner VDC Research conducted a survey with more than 700 engineers, software developers, and managers from manufacturers and engineering companies. The data represents the portion of manufacturers using various technologies for Internet of Things products, not the percentage of product units. For example, as you can see from this chart, one of the questions they asked is about the use of LP1s and various IoT products. And we can see here the blue bars were current products, that is, stuff they're making this year. The black bars, what they expect to be using it 2 years from now in 2025. And we can see that the LoRaWAN technology weeds in the responses from the survey, not only currently, but also expected into the future. Somewhat interestingly, I think, is that NB was expected to be more popular than LTEM in 2 years, particularly in China. Sigfox was represented but expected to decline slightly, although this survey was taken before the acquisition of Sigfox by Anubis. Also, as part of the forecasting process, look at the installed base of units, which is more than just the total number ever shipped, because units get taken out of service periodically. They get retired from service. They break down and die periodically. There's also a lag time from when they're built until when they actually get put into service. And here we're showing two variations of the same thing: the worldwide total of active installed units by these technologies in the top chart. And then in the top chart, the light blue portion of the bars is NB. And you can see that is quite large. That's primarily because of the impact of China on the market, where NB has been actively encouraged in a variety of ways by the Chinese government. So the chart on the bottom shows the set total is effectively subtracting out the market for China, not just for NB, but the other technologies as well. And we can see in the lower chart, the brighter blue bars on the bottom are LoRaWAN. And we can see that LoRaWAN is expected to maintain its position as the single largest of those technologies outside of the China market. In the global markets except China, LTEM will remain the biggest competitor. In the last slide, we said it's possible that the NB could take over the second place on a worldwide basis, but that was including China. When we look at the market excluding China, we still see LTEM being the biggest competitor for LoRaWAN. And if we look at that installed base by vertical market and use cases, we can see here utilities and metering account for the single largest chunk, and this is the entire LP1 market, not just LoRaWAN. So it includes Sigfox, D, and LTEM. The reason the utilities and metering market is the biggest chunk is because those tend to be very large deals that include high numbers of units. So utility installation for gas or water or other kinds of meters would typically be on the scale of hundreds and thousands of units. In some cases, millions of units in a single deal. That's pretty rare in the other use cases. So the utilities chunk is very, very substantial based on the number of units that are installed. And we anticipate that will continue to be the case where LoRaWAN specifically and the other LP1s are really good solutions for the utility metering kinds of applications. Logistic and supply chain applications come in second here. Generally, that means asset tracking in most cases. Those assets could be cargo shipment, for example, or warehouse and inventory kinds of tracking applications. And as we go down the line, building automation and smart home, that is primarily a commercial building automation. When we talk to consumers, the average person, when they think about the Internet of Things, they think of smart home technology. You know that Nest Thermostat by Google and some more kinds of smart home controls, but that smart home portion is quite small overall in the Internet of Things. Building automation in general is much better in commercial real estate kinds of applications and office building management, for example, where the building owners and operators are trying to keep track of lighting systems, heating systems, and room occupancy, where they can turn off the lights when nobody's there and track and understand patterns of usage, which meeting rooms get used most frequently, for example. Industrial automation in the Internet of Things as a whole is actually the single biggest vertical market, but it's been relatively small thus far for LP1 use cases. That's starting to come online more and more for LP1, but big use cases there for wired connectivity, especially Ethernet in the industrial automation market, as well as Wi-Fi and Bluetooth. And there are a number of wired technologies that are specific to industrial automation, but we are starting to see more LP1 use cases come up in that. Agricultural and environmental are basically sensors outdoors in the field. And LP1 solutions are what we refer to in that particular market. In this scenario for wireless connectivity, it's not so close that people can necessarily use cellular or local area networking technologies. And it's not so far that they have to use satellite-based technologies. It's in that just right applications for low power, wide area networks. And that's one, the agriculture and environmental, we do see that growing quite substantially from a sheer number standpoint. Automotive in transit includes both in vehicle, although that's relatively small for LP1s. Today, we will start to see some vehicles, particularly commercial vehicles. Trucking, for example, adding LP1 kinds of functionality, but also transit, including trains, planes, and automobiles of all sorts, and that also includes transit infrastructure. So parking lots, toll systems, things of that sort where we'll increasingly see use of LP1s. And then lastly, I'll mention the medical and healthcare that includes some standalone medical devices. For example, the patient's wearable devices can be tracked remotely by doctors or medical services. And it also includes the healthcare business more broadly. Hospitals have hundreds of pieces of equipment, and it's just a challenge for them to understand where that equipment is, how it's being used, how often it's being used. Does it need maintenance? Does it need new supplies? They need to understand whether it is operating correctly or not, and something like that. These are the typical applications where LP1 technologies have been widely adopted. If you've been following the industry of connected things for any amount of time, you've likely seen a number of new buzzwords creep in. What started being called machine to machine was mostly moved to the Internet of Things. And you've probably seen the artificial intelligence of things mentioned a time or two. What's the difference between these terms? So what is exactly the machine to machine? A simple way to describe machine to machine is basically connectivity, is exchange of information from one machine to another, or from machines to other machines directly. And in Internet of Things, the machines actually communicate to a cloud server, and the other machines, which actually need that information, would get this information from the cloud server or would be sent information from the cloud into these machines. So in case of Internet of Things, actually, it's much more complicated than machine to machine. Both terms relate to the communication of connected devices, but machine to machine systems are often isolated, standalone networked equipment. Internet of Things systems take machine to the next level, bringing together disparate systems into one large connected ecosystem. So, based on the machine to machine communication without human intervention, Internet of Things extends to include internet connectivity for devices, enabling them to send and receive data over the internet. Artificial intelligence combines the power of Internet of Things with artificial intelligence algorithms and machine learning capabilities. So what I want to say is the evolution of machine to machine, Internet of Things, and artificial intelligence of things has been driven by advancements in wireless communication technologies, sensor technology, cloud computing, and artificial intelligence. Machine to machine started with wired connections, but later shifted to cellular standards like 2G, 3G, and 4G. Internet of Things allows devices to connect to the internet, which has led to smart homes, connected cars, etc. Our IoT combines Internet of Things with artificial intelligence and machine learning algorithms, leading to more efficient operations in various industries. The development of machine to machine, Internet of Things, and artificial intelligence of things has resulted in a surge of connected devices and the expansion of the digital economy. This has unlocked new use cases and business models that were previously impossible. Against the AIoT background, the Milesight team is seeking to break through the boundaries and find more possibilities. Therefore, combining our accumulation in EP technology, AI technology, and Internet of Things technology, Milesight is set to embark on a completely new adventure in AIoT sensing insight. So, what is sensing or perception in Internet of Things? It means a machine's capacity to perceive vision, hearing, and touch information is ingested from the physical world into data through cameras, microphones, or other sensor hardware devices mapped to the digital world and then further understood using AI technology. In order to fully appreciate the value of this digital information and advance toward a more productive and interconnected society, it's further promoted to be used on a cognitive level, including memory, understanding, planning, and decision making. Sense, understand, interact. That's our understanding of sensing insights. Like it is displayed in this picture, if we work Internet of Things and artificial intelligence together, system will become smarter. It doesn't just collect the data. IoT internalizes the patterns and gives you the information you need to make the best decision. Our IoT will shape the future of the corporate world. Based on years of profound technical accumulation in the artificial intelligence of things technology, we'll work on extending the power of AIoT technology and launching more advanced products to achieve more comprehensive solutions. On the one hand, we will explore the potential of AIoT technology based on video security, introducing 5G IoT cameras, radar LPR cameras, and more to extend the application range. On the other hand, we will reform the product functions and applications by AIoT technology, releasing AIoT, vision sensors, and remote management routers. Meanwhile, VMS and cloud platforms are expected to be the central management of Milesight AIoT solution. After the detailed introduction of the AIoT technology and strategy, now I'm going to present the whole AIoT solution for you. You can find extensive AIoT products to extend the power of AIoT through Milesight, including intelligent video surveillance and Internet of Things related. Actually, it is not easy to find such an amazing solution that covers multiple innovations towards AIoT. But in Milesight, you can expect more even any top-edge technology. For Milesight always keeps a close eye on the market trend and will always deliver the innovation that requires visionary thinking to our customers. Milesight offers a comprehensive portfolio of products that empower end-to-end Internet of Things solutions. Their product range includes hardware, such as gateways, routers, and sensors, as well as software solutions, data management systems, and mobile applications. These products are designed to be highly interoperable and can be seamlessly integrated with one another to create a complete Internet of Things solution tailored to meet the specific needs of different industries, including smart cities, industrial automation, agriculture, and healthcare, with a focus on innovation, reliability, and scalability. Milesight is committed to providing high-quality products and services that enable businesses to unlock the full potential of the Internet of Things. Okay, that's all for today. I hope today's introduction will help you better understand the market trend from machine to artificial intelligence of things. In the end, for getting the latest news about Milesight, just follow us on our social media. See you next time.